Hello everyone, my name is Matt, and I will actually be filming my desktop instead of me because my laptop is out of commission. If you're also wondering why I don't simply put this into slideshow view, it's because the program I'm using to record tends to freak out and messes up the audio and video. So instead, we will be doing it in this basic view. So to jump right in, we will be looking at the temporal lobe. I'm going to be covering the auditory cortex, medial temporal lobe, the visual cortex, and schizophrenia. Starting with the auditory cortex, as you can imagine, the auditory cortex is involved in auditory processing. It's located in the superior temporal gyrus. The primary auditory cortex is located in the posterior portion of the superior temporal gyrus. This is the tonotopic encoding of pitch and frequency. Auditory sensations auditory sensations are only perceived if the stimuli is received by the cortical areas. So if you are able to shut off this area, you will not be able to hear anything. However, you won't be able to hear anything consciously, but you can still get a startle response. So if there's damage in the cortical area and someone slams a book behind you, you could still have a bit of an orienting effect or other tension-causing reactions. We've talked about Wernicke and Broca's area before, but just as a quick review, Wernicke spans the temporal and parietal lobe. If it's damaged, then the patient will have nonsensical speech, but they can still produce speech. Broca's area is in the frontal lobe, however, it works with Wernicke's area quite a bit. They are linked together via the arcuate fasciculus. If there's damage to Broca's area, it leads to speech production is heavily compromised. There was a study where the patient could only say ton, and they would say ton repeatedly. If the arcuate fasciculus is cut, the white matter band that connects the two, there's pretty severe dysfunction and speech production compromise. It's incredibly noticeable. Moving on to the medial temporal lobe. The medial temporal lobe is integral to memory creation and retrieval. Memory is split into somatic memories and episodic memories. Somatic memories are they're like facts, meanings, understandings, and concepts. Episodic memories are places, who, what, where, when, why. You see the hippocampus at the top of the screen, and the amygdala at the bottom. The hippocampus is important for short-term to long-term information consolidation, and the amygdala is important for processing memories and emotional reactions. Damage to the hippocampus leads to limited impairment to recall, so really not a huge difference. You can definitely tell, but if there's damage to the hippocampus and the surrounding cortex, it leads to pretty severe impairment. And there's a pretty cool study that looked into this and looked at lesions in the brains of monkeys and humans alike. It's an excellent study. It's linked at the end of this presentation if you guys are interested. I highly encourage you to go look at it. It's very well written. They laid out their goals pretty well. Actually, I'll just read off that they were working to show that this system is principally concerned with memory, that it operates with neocortex to establish and maintain long-term memory, and that ultimately, through a process of consolidation, becomes independent of long-term memory. And there were three pretty big things that they found, pretty interesting findings throughout this study. And the first one is that impairment was multimodal, which is essentially just means that memory is affected regardless of what sensory modality in which information is presented. So it could be auditory or visual. It doesn't matter if it's all compromised, which is cool because this also means that it's really the central hub for all that stimuli. Second is that immediate memory is intact. It's pretty self-explanatory. Patients are able to remember 2 to 3 digits for I think up to about a minute, but the more complex the digits got, or complex ideas, concepts, so if you give them like 5 to 6 digits, or you try to teach them different ideas and theories, it was very immediate. The impairment was very immediate. They would forget, I think as quickly as 10 seconds. Finally, impairment can occur against the background of intact perceptual abilities and intellectual function, which means people can still solve math problems or score very high on IQ tests or similar to what they were before any impairment occurred. So it doesn't change, it doesn't affect your learning, or I guess past learning, or no, it affects your past learning. It doesn't affect your cognitive ability to solve problems that are present. Moving on to the parahippocampal gyrus. It's located ventrally near the bottom of the temporal lobe. It's important for memory encoding and retrieval. It also contains what is called the parohippocampal place area, which sounds kind of funny, but it makes sense because it helps with scene recognition. So when you walk into your home or to school, the classroom, you know it's your home or the classroom or wherever you are. You recognize the scene. So damage to this area, as you can imagine, leads to people being unable to identify where they are based on the collective stimuli that we're just so used to. I mean, we take for granted that we just walk into a place and we know it's our home or wherever we are. It is important to note, though, that patients with damage in this area can still identify individual objects. So they can still figure out, that's a chair, that's a table, whatever. It's just the collective stimuli. They're lacking that ability to really put it all together. Some research is also being conducted in order to find out if the parahippocampal place area plays a role in paralinguistic elements of communication, which essentially means sarcasm or other social cues like that, which I think is hilarious that we need an area of the brain that helps us detect sarcasm. Moving on to the fusiform gyrus, there's a lot of different articles and theories about what exactly this gyrus does, so it's kind of cool. It's still under a lot of scrutiny. The biggest thing is prosopagnosia, which is face blindness. So you can know this person all your life, but if there's damage to this area, then you will not be able to recognize them by their face. These are bilateral structures that seem to react differently, but are ultimately interlinked and work together. And it says the left side recognizes face-like features, whereas the right side determines if it's actually a face. An interesting study looked at both the fusiform and the parahippocampal gyrus and how it relates to schizophrenia. It's pretty interesting. They found that there was a lower volume of both the volume of gray matter of both the parahippocampal and fusiform gyri, and the comparison subjects showed a larger left volume asymmetry, so the left side was larger than right. However, patients with schizophrenia showed the exact opposite, and I believe this was caused to a degradation of the left area. It wasn't any type of weird mutation where the right side was bigger. I believe it was the left side was destroyed or deteriorated. So it was cool. This study, I think, is the third one to kind of start looking at this gyrus and figuring out if of these two gyrus and really trying to figure out if they can relate to schizophrenia. And so far, the data is really pointing that this will probably become another area to monitor when patients are, if we think that schizophrenia is developing. Two other real kind of common temporal lobe problems would be Pick's disease, which is atrophy of the frontal temporal lobe. And this is interesting because personality changes, and it's kind of similar to Alzheimer's. However, with Pick's disease, personality changes before memory loss, and Alzheimer's memory loss it comes first and then personality changes. And they actually use that to kind of screen and figure out if a patient has one or the other. The temporal lobe epilepsy is another one. It's recurrent seizures that leads to sensory hallucinations and inability to process somatic and episodic memories. Kind of another standard terrible thing to happen. Here are the citations. The medial temporal lobe study is right here. This is the one that I encourage you guys if you're interested. It's a great study. They cover a lot of different types of learning and essentially what can happen, what certain specific areas and damages can lead to what type of memory loss, or if it's global or if it's limited. So it's an excellent read. And here are all the different areas that I covered. Hopefully I was entertaining enough for you guys. Thank you very much for paying attention. If you have any questions, please feel free to either catch me in class or shoot me an email or text me if you have my number. Bye.